No. Okay. Yeah. Well, that guy can play too, man. I could listen to him.
He's the keenest assistant.
Yeah. Okay, so we're looking at, and Fanny asked a great question. What does SI spark ignited? If you see CI, combustion ignition or combustion ignited. Okay. Now, the engine we talked about so far is called a 4-cycle or 4-stroke operation. And the strokes have to occur in that sequence we just talked about, or this thing isn't going to run. So the crankshaft has to make 2 revolutions, 720 degrees, to get 1 power stroke out of the cylinder. Okay? We good on that? Because you might see that on a test.
Can you say that one more time?
It's called a 4-stroke or 4-cycle engine.
And you will see that on a test.
Yeah.
If you're going to go for a mechanic position, I can almost guarantee it'll be on one of your tests here. I don't know about anywhere else, but they'll ask you, how many times does the crankshaft rotate on a 4-cycle engine? And your 1, 2, 3, and 4 are your possibilities for answers. And it's I'm really surprised how many people pick 4. 4-cycle, 4 strokes, there you go. But it's actually only 2.
Yep.
2 revolutions of the crankshaft on a 4-stroke engine. Because there's actually 2 of the strokes on each revolution of the crankshaft. The intake and compression is 1 stroke, and your power and exhaust is another stroke.
But it doesn't,
Revolution, yeah.
full turn revolution, right?
Yes, 1 turn, 1 revolution.
But don't you have to have for each valve?
Half a
one
revolution
full-
is 1 stroke.
Yes. The thirdly confuse you.
All right.
No, but for each valve, you have to have.
We'll go over this.
Stroke, right?
So it's called a 4-cycle or 4-stroke engine. Okay? 4-cycle or 4-stroke. Okay? So the crankshaft has to turn twice, or 720 degrees of rotation. Two complete rotations on a 4-stroke engine to get 1 power stroke per cylinder. Now,
How many degrees in the circle?
360.
So for the intake valve and the exhaust valve, you have to have 2 strokes on that 1 cylinder
No,
for each valve?
No.
No?
I'll go over it again.
Okay.
Okay. So the engine, SI, is often referred to as spark ignited. Okay. 4 strokes of the piston required to complete 1 cycle, 2 crankshaft revolutions. Now, we have a firing order. It's not 1, 2, 3, 4, 5. We fire it. We try to do our best to fire it at opposite ends of the crankshaft for a smoother operation and less stress on the crankshaft. So the firing order is 1, 5, 3, 6, 2, 4, 15, 36, 24. Okay? Now, when we talk about tuning up the engine and whatnot, we will have 2 cylinders traveling in the same direction, but not necessarily on the same stroke. When 2 cylinders, 2 pistons, travel in the same direction, either up or down, at the same time, they're considered companion pairs. And the easiest way to figure out companion pairs is find, for example, this is a 6-cylinder engine, right? So any 2 cylinders that add up to 7, 1 more than what you have, are companion pairs. 1 and 6, companion pairs. 2 and 5, companion pairs. 3 and 4, companion pairs. That means they're traveling in the same direction, not necessarily on the same stroke. Okay, so let me review those strokes for you. Now, On the intake stroke, the cylinder is moving down in the bore. Okay, half a stroke. Down. Piston is acting like a pump, drawing in air and fuel past the open intake valve. One stroke. Intake. When the cylinder reaches the bottom of its stroke, bottom dead center, the intake valve is going to close and trap the air and fuel in the cylinder. And the cylinder is going to move up. Stroke number 2 changes direction. And it's going to compress that fuel and air in there and heat it up. It's traveling in the up direction. Compression stroke. Valves are closed. The air trapped inside gets compressed, builds up heat. Okay? That's stroke number 2. We've made one crankshaft revolution. Intake, compression. Okay? 2 different changes in direction. Intake, compression. Near the top of the compression stroke, near top dead center, and we talked about why it's near, not exactly at top, I'm going to light off my spark plug. Going to set up the flame front. Going to consume or combust the fuel-air mixture and release the heat in the fuel, pushing the piston down. Stroke number 3. That's the power stroke. Okay? That's the money shot. That's what we're working for.
I have a question. Would the gap on the spark plug, like a defect on the gap?
Yeah.
Spark plug affect anything in there?
Oh yeah, absolutely. If I've got too much gap, I don't have enough pressure to push the electrons across that gap to ground to complete the path. I won't generate heat. I won't fire it off. We call that a misfire. Great question. Exactly. That's why you have a preferred gap. The engineers know that the ignition system is capable of producing a certain amount of voltage. And the required voltage to fire the spark plug varies depending on how much work the engine has to do. Right? So if my gap is a little off, when I start getting into the more heavier demands on the engine, I could develop a misfire. Okay?
So you're saying that you can start the car running normal, but when you start with more load, that's when you have the issues with the spark plug?
You possibly could.
So like, for example, if you replace the spark plugs, you won't realize that you missed the gap until it has heavy load?
Possibly. You could also have a dead miss at idle. And as the electronics of the ignition system pick up more load, they start to administer more voltage. And as it gets loaded, it runs better. But at idle, since there's less load, there's less spark available, and the cylinder misfires.
So the,
Oh, what fun we have.
so the spark plug gets different voltage every time?
Yep. And we fire it multiple times per power stroke to ensure that the flame front remains established. That's called multiple spark discharge. General Motors nailed it. They put it on the key marrow. So they'll light it off multiple times. That way, if I light my spark plug once and my flame front does not establish, I don't burn the fuel, I've got a misfire. But if I multiple fire it, and I fire it the first time, the flame front doesn't establish, but I keep firing it, it could fire and establish the flame front, combust the materials, and produce a power stroke.
I always wondered what an MSD ignition was.
Multiple spark discharge. And you know why they did that? Emissions. To reduce idling emission, because that's where the engine's going to misfire the most.
Okay.
Unloaded, low speed. It's going to misfire the most. That's why Chevrolet came up with MSD. Nissan tried it with multiple spark plugs per cylinder.
Chevrolet created MSD? So the MSD you see today that's Chevrolet?
That was derived from Chevrolet.
Oh.
Cummins uses it on the natural gas motor because of the low heat in the fuel. It's hard to light that beast off. So we have to fire my spark plug multiple times.
You wanna make sure everything's completely burned, otherwise emissions are high going up.
And when we talk about,
Converter emissions on
That helps, but you could also clog up your catalytic converter if you run it.
yeah, your catalytic converter does not like raw fuel. It'll damage your O2 sensor, damage your catalytic converter, and you've got all kinds of problems. That's why we went to a capacitive discharge, and we'll talk about that in the ignition section. But the difference between a capacitor and battery voltage is a capacitor I can discharge instantly and recharge instantly, where a battery, if I discharge it instantly, I'm only going to do that once. Then the battery's wasted. So I use a capacitor to assist in firing a spark. We'll get into that when we get into ignition. So on the power stroke, the piston is now forced down by the rapid expansion of gases. That's stroke number 3. That's a little over a turn and a half. The final stroke, the exhaust stroke, the piston's at the bottom of the travel forced down by the combustion stroke. I start moving up. I open my exhaust valve. The piston moving up in the bore is forcing out the spent exhaust gases. Actually, I should say exhaust mixture. Near the top of the exhaust stroke, the inlet valve is going to open using what we talked about earlier, thermodynamics and the law of relativity, where two parts can't equal the same space. I'm going to use the displaced temperature to force the cold air to the bottom to push the warm air to the top, and then use the piston to narrow the size, push it up in the bore, and force the hot gases out of the valve. Valve overlap.
That's why the engines have the thing where it recycles the...
No, that's emissions. The biggest thing, and Dean Mondar still to this day swears that EGR is to reburn any leftover fuel. You can't argue that with him.
No, I think he did do
Oh.
some research and found out that he was mistaken.
Okay. Yep. Okay. In a nutshell, what that EGR does is you got to figure the temperature in the combustion chamber at the time of ignition is somewhere near 2200 degrees. Okay? The exhaust coming out of the tailpipe, once we run it through a cooler, is somewhere near 700 degrees. So that's like air conditioning. So what we do is we put that exhaust air, which at this point, because of the chemical reactions of combustion, is what they call inert. It will not add heat to the combustion stroke. But what it does do is it cools the combustion chamber so we don't hit that 2600 degrees Fahrenheit and make smog. But now we've created another problem. Since I've cooled the combustion chamber, I'm not burning all the gases. And because I'm not burning all the gases, I'm going to suffer a power loss. This is why Dodge had to go from 5.6 to a 6.7. Because of the additional emissions requirements. EGR, I had to take space that I could put a combustible mixture in. I had to take some of that space and put an inert mixture in to cool the combustion chamber so I don't make smog. So the power loss is I've got basically dead space. I can't do anything with it. I got to put this inert gas in to get the emissions down, or I can't run that motor.
Specifically oxides of nitrogen.
Bingo. We know it as smog. Frank and I have been around for stage 1 smog alerts. You look out and you can't see the freeway.
Can't see
Can't see the mountains.
mountains or anything.
You walk out, your eyes are watered. What's wrong? Nothing. Smog.
It's better now, but even still, if you're flying into the LA basin from somewhere like Colorado or,
Nevada.
yeah, you come in and you can see the orange haze still. It's not as bad as it used to be though.
Oh God, yeah. You could. I grew up by the freeway. You could smell. You remember you get a carbureted car coming up next to you, it's running rich. That smell. You could smell that coming off the freeway on a hot, stagnant day.
We do
I used to have
it.
such overlap on
The
my
bus.
cam in my car that it would bring
Close the
tears to
window,
your
it
eyes
gets
at
in
aisle
there
if you
anyway.
stood behind it.
Yeah.
It's over it.
Very low.
But you got off the light fast. All right, now we're going to talk about some terms that you've probably heard that you probably may not understand. Recently, now that we're getting back into the days of cars that you really like to drive, what is it, the Hellcat 1,000 horsepower?
Is it?
Yeah. What the hell are you going to need that around here?
Racetrack.
Where's there a racetrack around here that you can get on?
Fontana.
Pomona.
Can you go up and just say, hey, I want to drive on your racetrack?
Yeah.
Yeah.
No.
It was on Woodchip Run, right?
Yeah, drag, but you're not going to be able to do hot laps.
There is one that you pay and you can go in with your card, but you need to prove that you can drive.
Well, there's half the population of California.
They do every day on Main Street.
Yeah, trying to prove they can drive it. Some of them aren't that good at it.
Main
Yeah.
Street, oh.
All right.
It's called acceleration ramp to get on the freeway. For a reason.
You know,
That's the best time.
I damn near hit this ignoramus. They went up the on-ramp at 35 miles an hour, got to the top where you're supposed to merge and stopped and turn on their turn signal. I'm roaring up the on-ramp. By the time you get to the on-ramp, I'm at freeway speeds, 80. I'm like, this fool is stopped. So I had to jerk hard, get around him. Yeah, I wish I had my old 72 Ford pickup with the tow truck bumper. I'd have taken him out. Boom! There you
You
go.
would have taken your truck out too.
No, this front end was built. My brother built it with some crash and burn guys, so it was meant for impacts of up to speeds of 45 miles an hour. Man, I miss that truck. Now, what is horsepower? Got 1,000 horsepower. What is horsepower? Who came up with the term horsepower? Maybe I can help you this way.
The guys invented the train.
James Watt invented the choo-choo. Yeah, the train. Now, at the time he invented this thing, America was pretty much an agricultural-based economy. Horse, buggy, plows, fields, everything. So if you wanted to take your stuff to the market, you would throw on the back of your buckboard, you hooked up your teams of horses, and you took it to the market. So along comes James Watt in this big iron lung, that's what they called it, steel machine, iron horse. And he had to sell this thing to investors. And at that time, figure you're back in the 1870s, right? And, machines were not very common. So here's this thing making steam and all these noises sitting there. And you're like, what's it do? Well, it moves things. Well, I move things with my horse. This thing can move as much as 10,000 of your horses. Holy cow. So I could team up 10,000 horses and this thing will move that much? Yes. It's the rate at which work is done. It's an element of time. How fast can you do work? I can do the work at the rate of 10,000 horses. Okay. Horsepower.
Wasn't it something like a pulley, like 3,300 pounds or something?
That is,
A little diagram.
yeah. I'm going to go there. Hang on.
There you go. Well, looky here.
So there's many definitions for horsepower. One of them is 33,000 pounds, 1 foot in 1 minute. How much effort or how much work does it take to pull 33,000 pounds, 1 foot off the ground in a minute? This one is 5-pound weight, it's lifted 5 feet. The work done is 25 foot-pounds. Okay? Working is a measurement of distance and force. It's the rate at which work is done. Now, what is the work that we're doing? Torque. We're twisting the crankshaft. Torque is a twisting effort applied to a crankshaft at a 90 degree. And ideally, when a guy's building an engine, he wants that combustion stroke to happen when the rod that connects the piston to the crankshaft is at 90 degrees to that crankshaft. That's when the optimum amount of force is going to be applied to the shaft. That's why inline engines make more torque than V engines. So torque, the standard of measurement is foot or inch pounds. The twisting effort is equal to the distance from the center of the shaft the point at which it's delivered, okay? So we look at it as when you tighten the bolt to 90 foot-pounds, you're applying a twisting effort of 90 pounds at the center of that bolt. When the engine fires off and runs, we're placing pressure on top of the piston from the combustion process, pushing the piston down in the bore, which is taking the rod that connects the piston to the crankshaft and forcing the crankshaft to rotate with a certain amount of force. Now, does heat value have an effect on torque rating? If I can put more pressure on that piston, I can force the crankshaft to twist with more force. This is why diesel fuel is the preferable fuel for your over-the-road trucks. Because of its high heat value and its release of heat when it's ignited, it puts more pressure on top of the piston compared to other fuels. And if I'm pushing harder on the piston, I'm causing that crankshaft to turn with more force. Now, when you spec things out, it's not, oh, I want a 1,000 horsepower diesel engine because I'm going to pull my Coca-Cola trailer through town. Well, horsepower and torque cost fuel. Fuel costs money. Fuel emits emissions, and when you have a corporate emissions average you have to stay under, maybe you don't need 1,000 horsepower to pull your Coca-Cola trailer through town. So here's how this works. My brother used to build dragsters for Chevrolet. Now, a dragster has to do a lot of work quickly, but it doesn't have a lot of work to do. A dragster weighs 1,900 pounds. So there's not a lot of work to be done, but the work you have to do it quickly. So you're making 1,400 horsepower, 389 foot-pounds of torque. It's not a lot. My Jeep probably makes that. Your car does, easy. But I have to do it fast. Horsepower, rate of work. Now, you ever watch Highway Through Hell, Jamie Davis Towing in Canada? He just bought a new wrecker. 70-ton rotational wrecker. 2,100 foot-pounds of torque at 800 RPM. It's got a bunch of work to do, but time's not really a problem. 800 horsepower, that's respectable. But the thing that's going to make this truck work is the 2,100 foot-pounds of torque. It's capable of a lot of work. Just don't think you're going to win a drag race with it, because you won't.
I bet most of you think that your bus out there has a lot more horsepower than your grocery getter, but it doesn't.
280 horsepower.
280.
Your grocery getter has a lot, yeah, the torque is what gets.
It's about 700 foot-pounds of torque. The diesel variant of that at 280 horsepower is about 900 foot-pounds of torque. This one actually, I think I looked it up, is like 686 foot-pounds on the gas motor, ISLG. My 5.9 Cummins in my motorhome was 300 horsepower, 900 foot-pounds of torque. Okay. Now, I could put 1,000 horsepower in there and make 200, 300 foot-pounds of torque. That motorhome would not go well at all. Because it's doing a little bit of work, but it's doing it quickly. You know, the Three Stooges? Right? High horsepower, low torque, right? Okay? You will never forget that now, will you? See, who says the Three Stooges aren't educational? Okay? Okay? But that might work. A dragster is high horsepower, low torque. But don't think you're going to take that 1,400 horsepower, hook a 53-foot trailer up, load it to 80,000 pounds and go up the Grapevine. Not at 386 foot-pounds, you're not. Not with any efficiency. Don't think you're going to roll Jamie's new wrecker out there with 2,100 foot-pounds of torque and 800 horsepower and turn some good times in the quarter mile. You're not. It's going to do work, but it ain't going to do it fast. These top fuel dragsters, 350 miles an hour in the quarter, they're making close to 8,000 horsepower because they got to do a lot of work in a very short period of time. They don't need to make much torque. What's a top fueler weigh? 2,000 pounds? Maybe. Especially if the driver's on Weight Watchers. Just saying.
Just
Has
railed with,
there ever been like
fiberglass.
a bus like fully loaded, like weight? Like how much would it weigh?
Those buses come in around 19 tons.
Empty? Or with
Yeah,
a
I
bunch of
think actually-
customers?
No, they're GVRW, the gross vehicle weight rating, GVWR, how much they're allowed to carry is about 19 tons, fully loaded. That's
19
with
tons.
you, the driver, fuel, engine, everything, 19 tons.
If you do the math, that's about 38,000 pounds.
Yeah, 38,000 pounds.
Wow. Just not an Arctics.
Oh, Arctics are coming in about 21 tons, 22 tons. It's 110,000 pounds.
And why is the reason we can go on the freeway with more than 10 passengers standing?
I have no idea.
If the bus can afford
Well,
it?
the gross vehicle weight rating is done with the average passenger assumed to be 150 pounds. Sorry. I don't know what decade that came from. So they say you can have,
That's a fifth grader.
yeah, right, not today. You've been playing video games for a while, no. But, so they figure, your average 150-pound passenger, you can put 50 of them in there, but there's only 44 seats, or whatever.
We actually have an exemption to the GVWR with the CHP to run our buses because
Yeah.
they're actually overloaded.
They're overweight. Every car, if you look on your door or on your glove box, they'll have a weight rating, how much weight you can put in that car, and that weight includes the driver and everything. That's why you see these truck tractors going over the scales. Okay, they're weighing to make sure he doesn't carry too much cargo. Now, there's several ways you can ride a trucker for overweight. There's tire weight, bridge weight, axle weight, vehicle weight, kingpin, the fifth wheel weight. There's all kinds. There's like 7 different ways.
Like,
Especially the independent trucks.
but like in an emergency, like the other day, I was driving the 83, and a bus from another company broke right there on the carpool lane. So radio called me and said, pull over and load all the passengers. So
That's illegal.
Yeah, that was.
If you're over the vehicle weight rating, if anything were to have happened, not you specifically, but we'd be on the dime for a lot of problems. You're running the vehicle overweight, knowingly running the vehicle overweight, whatever liability may happen, we just owned it. That's illegal. You can't
So that
knowingly
was
load the vehicle
illegal?
beyond, huh?
That was illegal?
You can't knowingly load the vehicle beyond its design weight capacity. I don't believe there's an emergency exemption in the vehicle code for that. So for him to tell you to do that, I'm not making policy. I'm not saying what he said was wrong, but if you just look at the letter of the law, that would be illegal, knowingly overloading the vehicle. Because when you do that, you've now put more weight on the vehicle than the brakes are designed
brakes,
to
yeah.
deal with.
Oh, that's the reason. 'cause
That's
the
part of
brakes,
it, sure.
Not because the.
That's part of it. Same thing with the steering. Same thing
You'd
with
be
the brakes. Same thing
endangering
with-
all these people's lives by doing that.
And number one, loading and offloading on a freeway,
Well, I have officers helping the people to go on my bus.
well, is that cop gonna sign off if someone gets hit by a car?
Uh,
No.
Just saying.
Well, I
If it-
just did what I was.
No, I'm saying, and you did the right thing, but somebody higher up the food chain needs to rethink that idea.
Hey, Mike. I was thinking about something.
Wait a minute. All
You
right.
gonna sit down?
Yeah, I think I got it here.
I got a good way for everyone to be able to remember the firing order.
Oh, don't say it.
You know the one? You know the one?
Well, yeah, 15 too young, 36 too old, but 24 is just right.
Yeah.
Yeah, well, I wasn't gonna say that.
Oh my goodness.
Of course, at my age, 36 ain't bad either, you know, I'm just saying.
Yeah.
It's like, yeah, if you wanna.
Yep, it works.
I try to be good, I mean, I do.
Not with me.
Oh, we didn't give the trigger warning before that, though. Oh, well. I tried.
Yeah.
I don't know if that's a good thing or not.
You'll never
Danny,
forget it.
that look bothers me. All right, so are we good with the difference between torque and horsepower? Now, when you say horsepower, though, there's a couple of different ones of those, too. Brake horsepower rated power. Okay, so we look at this a lot of different ways. When we talk about brake horsepower, or brake horsepower rated, it's using a Society of Automotive Engineers standard, using a Prony, and that's not misspelled. It's not Pony, it's a Prony brake. It's a Prony brake or dynamometer. It measures the net horsepower with deductions for load. So it's like your paycheck. It's what's left over after everything's taken out. That's the best way I can describe it. So if I've got a horsepower rating, net horsepower, that means it takes into consideration the loss of power developed from the alternator being forced to turn, the air conditioning being forced to turn, the power steering being forced to turn, the internal frictional losses derived from the oil pump taking power off the engine to turn, the water pump, everything. And what's left over is the net horsepower rating. The frictional losses through the drivetrain, through the transmission, through the differential, through the axles. That's not what Dodge is telling you when they say 1,000 horsepower. Continuous horsepower is how long can this engine make the horsepower rating without blowing up. That's not 1,000 horsepower. Okay? Indicated horsepower. So peak horsepower or continuous horsepower is how you normally drive the vehicle. That's the continuous horsepower rating. Okay? Peak horsepower is the amount of horsepower the engine can produce for a short period of time. That's not even what Dodge is telling you when they say 1,000 horsepower. The rating that Dodge is giving you at 1,000 horsepower is with no oil pump, no water pump, no alternator, no AC, no power steering. So it's being lubricated by an external force and it's being cooled by an external force, and they're running it to read what's really coming off the back end. You will never see that. Now Dodge dealers will tell you, oh, hey, well, he doesn't want salesman. He's there to sell you a car. Okay? Road horsepower at the wheels is the most realistic reading you can get. That is, they drive the car, you all been to the smog station, right? They put it on those giant rollers, right, and they run it. That is a chassis dynamometer. It measures road horsepower, what you physically have available to use. Now, out of that 1,000 horsepower Dodge that you just paid for, and the guy told you, oh yeah, you have 1,000 horsepower on the road. No, you don't. You got about 750, maybe. Internal frictional losses to turn the motor. Frictional losses used to compress the fuel-air mixture. Frictional losses to drive the water pump. Frictional losses to drive the oil pump. Frictional losses to drive the air conditioning. Frictional losses to drive the, what did I forget? Power steering, air conditioning,
So like that
alternator.
Hellcat is less than, yeah.
Yeah, it's, and I'm not saying that to be disparaging, but they're not telling you everything. They're giving you a rating that looks most appealing.
1,000 horsepower with just the engine.
It's just the engine. Crank.
On a dyno.
At sea level,
Yeah.
at 70 degrees,
Yeah.
with a certain density in a lab that you will never see in the real world.
And there's a full moon out.
On a Tuesday.
Enough to move the horse, not the wagon.
Yeah, pretty much.
Like your fuel mileage, miles per gallon, yeah.
Yeah, may vary. There's the understatement of the damn year.
Especially when you get some engine.
There's your weights of an Excelsior.
The 40-footer is, wow. 42 tons? Or no, that's 20, okay, 21 tons. And 60-footer is 23 tons. I still wouldn't want that running over my foot. So continuous horsepower is what it's going to make for long periods of time. Peak horsepower is when you stop on the throttle to get around grandma and her Nash Rambler blocking your way. Net horsepower is what's at the back of the flywheel with nothing else on it. Okay? Road horsepower is what you got available. Okay? Now, the formula for this is to figure torque, or to figure horsepower. Indicated horsepower is calculated using the horsepower formula. RPM times torque times a constant 5252. Now, rated power is the power measured at the engine flywheel without any of the accessories on it. Okay? So horsepower is the rate we do work. Now, 1 horsepower is defined as 33,000 pounds lifted in a minute. So the circumference of 1 foot circle, see, I'm reading this for the first time, is 6.2832 feet. Since these are both constants, you divide 33,000 by 6.2832, and you get the 5252 number used in the horsepower formula. So if you notice, when you look at an engine spec sheet, they give you a peak horsepower and a peak torque, but they don't occur at the same RPM. For instance, you might reach peak torque at, well, let's use this Cummins out here as an example on ISLG. Now, I'm kind of making this up, and I'm kind of trying to remember it. It's going to reach peak torque at somewhere near 1,300 horsepower, or 1,300 RPM. Okay? It's going to reach peak torque, or it's going to reach peak torque at about 1,300 RPM. That means it's doing its most work at 1,300 RPM. Not doing it the fastest, but it's doing the peak work it can do. It's going to do its most fastest work at somewhere near 3,800 RPM. But because of the physics of the motor, it's going to be doing less than peak work, but it's going to be doing it at its peak speed. So your torque curve would look something like so you hit your peak torque usually first at somewhat of a significant lower RPM. The efficiency of the engine, or how fast it can do work, peaks at a higher RPM. But you'll notice at that same RPM you're at peak horsepower, you're something at less than peak torque. You see what I'm saying? Now, this isn't necessarily a bad thing depending on what you're doing. If you're going down a relatively flat road and you need to be somewhere quickly, well then you need the engine to work fast, but because it's not under a heavy load, you don't necessarily need peak amount of work. Right? But if you need the maximum amount of work because you're going up a hill, you're not going to be over here in your RPM range. You're going to be throttling back about, now you're not going to be going fast, obviously, because here you'll get the most efficient use of your fuel. Pounds per hour of fuel. Okay, so you're going to be chugging up the grapevine at 40 miles an hour, but you're going to be using the most efficient use of the fuel, and you're going to be making the less amount of emissions. Now, yeah, you can step on the throttle and go up faster, but you're going to be less efficient fuel-wise and more emissions. See what I'm saying? Now, so horsepower equals torque multiplied by RPM divided by the constant. So you can see it's a measurement of rate of work. Because there's generally a limit on how fast you can spin an engine, having high torque allows for greater horsepower at lower RPMs. Okay, this is hot rod stuff. If I want to build a hot rod, I want to get my peak work and my most efficiency as relatively close as I can. Okay? I don't want a wide spread between maximum horsepower and maximum torque. I want to try and get them as close together as I can. Okay? More horsepower generally means the car has a higher top speed. More torque generally means the vehicle has less top speed but more ability to work at lower engine speeds. So if I'm pulling a fifth wheel, I'm not going to put a Ferrari motor in it. Right? If I've got a Ferrari, I'm sure as hell not going to drop in a truck motor because I'm asking it to do two different things. I don't anticipate going 110 miles an hour while I'm pulling a fifth wheel. Well, maybe me, but that's a different story. Okay? Whereas I don't anticipate pulling a 14,000-pound trailer with my Ferrari. Two different vocations. If I'm pulling a trailer, I want my peak torque to come on at a low RPM. So I can use a maximum amount of work at the most efficient use of fuel with the least amount of emissions. If my goal is I need to go fast, then I'm going to have an engine designed to get to my peak horsepower. See, the old term torque gets you going, horsepower keeps you going. I need a lot of work to get that bus off the curb. But once I get it off the curb, if I work fast enough, I can keep it going and I don't have to do as much work to do so. Make sense? Okay. Now, engine performance charts usually use a horsepower curve with indicated horsepower RPM. It's kind of what I tried to do here. They generally, if you go into a showroom and you ask the guy at the Dodge dealer, say, hey, let me see the torque curve, the horsepower curve, and the fuel used per hour curve, that one will probably throw you. He's going to want to show you the horsepower curve because that's the big number. That's the 1,000 horsepower. So when he shows you that horsepower curve of 1,000 horsepower, ask him where that measurement was derived from. Was that taken off the back of the motor with nothing on it? Was that taken off the back of the motor with all the parasitic loads on it? Or was that taken off the road wheel? And can I drive it at 1,000 horsepower all day? Probably going to say no. Because here's what it's going to look like. And I'm not picking on Dodge. I could very well say Camaro or Ford. It's either or. So your 1,000 horsepower is going to come in at a 5,000 RPM. What kind of car do you drive?
Nissan Sentra.
Okay, your tachometer, I believe you probably have one, probably has a little red line starting at around somewhere near 3. Right? I'm guessing.
You're
Chris,
talking about the red line, right?
Yeah, the red line.
Red line.
Chris, you got your Highlander still, right?
Yeah,
Where's your red line start on that?
probably around 4 or something like that.
$4,000. You got a twin overhead cam V6, I think, right?
Yeah.
Okay. So even at $4,000, he's still got to go 1,000 RPM past that to get to his peak horsepower. Now that peak horsepower is what they call intermittent. So I'm driving down the freeway with my cooler full of brewskis and 4 of my drunkest friends in the back of my Dodge Charger, and I'm going to go around a motorhome. So I'm going to drop the throttle, and briefly I'm going to hit that $5,000 mark to get around the motorhome. I'm going to cut him off because I'm drunk and get out of the throttle. Now, if you tried to drive from here to Bakersfield with your foot in the throttle making 1,000 horsepower at 5,000 RPM, you ain't gonna get there. Because it's gonna blow up. Red line for, how long did it take you here to Bakersfield? With no traffic. I know, huh? You're like, wait a minute, what are you gonna do with red line?
At 5,000 RPM?
Yeah, well, if it's a stick, I'm in first gear, right? But, I mean, you can try it, but here's where that's gonna get you in trouble. That's gonna go in your abuse file. It is. Every black box, let me back that up. Your higher end automobiles are gonna have a file. That anything that operates outside of the specific parameters of that engine transmission combination is going to get logged in that file. So if you hit peak horsepower for a few seconds, that's not abuse, that's peak demand. We'll give you that. But if you try and drive from here to Bakersfield that way, if you get there, or even if you don't, and then you go to claim warranty, they'll go to that abuse file and say, no, not happening. Okay? Not happening. Okay? Now, your torque curve will come in and they'll have another line. We'll call this significantly lower. And you operate at peak torque all the time. Peak torque usually means better fuel economy, less emissions, and less or lower exhaust temperatures.